Project 3 in this course builds on Project 2 by adding operator overloading. I'm starting by looking at the project requirements and creating a little to-do list. Before adding the operating overloading, the code from Project 2 needs to be updated to fix a few things the professor noted. In the fraction input class, instead of having separate input boxes for the fraction numerator, denominator, and whole part, the user should instead input one string with a variable amount of white space and sign indicators, and tokens will then be extracted from that string and parsed, and the parsed values will be used to populate the fraction objects. I'm setting the last iteration of Project 2 as version 0 for this project and making a copy to begin work on version 1 of Project 3. A version control system like Git would be better here, but this project just needs to be lean and simple to meet specs. I need to focus on the fraction input class first. I'm changing the name of the old declaration to render it irrelevant for the time being. I'm reviewing how fraction input was defined because I'm going to need to reuse some of that logic in the new fraction input class, and I need to figure out what to keep and what to toss. Ultimately, I decide just to delete the definitions for the previous fraction input class and go off the header file to see how the code is structured. I can always check the old project if I really need to see how those were defined, but the fraction input class is going to be pretty different now and it needs to be totally reworked. Now I attempt to compile the program just to make sure it doesn't compile because I just deleted a bunch of logic it needed. Now I'm changing gears a little bit and starting work on the input widget. It makes more sense to start with the input widget because the fraction input uses the input widget, so it's sort of the smallest component that needs to be changed. I had previously made the widget with an eye to having different modes, as in there was an integer validation mode, a string input mode, and so forth. I just decided to scrap the integer validation mode functionality and just have it always get strings. In this case, unlike the fraction input, I'm not scrapping the whole input widget because I really only need to change a couple of functions. Now the input widget, instead of having some constant modes, as fun as all caps values are, I decided to go for a few different Boolean flags that control different aspects of input validation. This gives a little more customizability too to what you want the input widget to actually do. This is pretty easy to refactor because I never really set up the validation fully before anyway, so I don't have to change a bunch of logic since I never got around to writing it. All the input mode validation flags will be set with one big setter function. I think that's a little more convenient, and you can figure out what the flags are from type hints, even with nostalgic dev C++. Now that input widget has different members, the constructor needs to be reworked a little bit. The main thing that needs to be changed with input widget is how it validates. Previously, when InputWidget was in integer mode, it didn't allow spaces or non-numbers or other non-valid characters. It prevented the user from ever typing bad input in the first place, validated everything at the character level, and guaranteed input could be parsed to an integer. Now, each part of the character level validation has been associated with a particular flag. So the validate char function will operate differently depending on which flags are set. The way I'll use it with fraction input, it will still prevent the user from even entering letters, but they can input spaces and tabs, for example, as long as the flag for that is true. I always thought the day might come when I would need the cursor back macro, which moves the text input cursor on the console back some number of spaces. I need that because I want the input widget to handle the user input of a backspace, as you might expect, deleting the last character of the string. All I needed for the cursor back macro was a little bit of a rewrite from an older macro I had set up to work with printf, and I'm just setting it to work with cout. Maybe some folks would think that a name like operators are allowed is a bit long for just a flag, but I say the longer the better. I want to know exactly what this flag does, and I kind of like it to read as a proposition grammatically when I'm using it. With the input widget definitions basically done at this point, I'm back to finishing the rest of the fraction input definitions. The fraction input class has its own private members for whole, numerator, denominator, and positivity, which it gets from what it parses. It will only set a fraction object to those values if they were all parsed correctly. Now, when the fraction input class displays, it needs to show the value of the fraction as the input string. So string interpolation could be really handy here. Now, I'm pretty sure you can't do string interpolation in C++ right out of the box like you can with some other languages, but I need to check, so I need to search it. Fortunately, C++ is one of those languages that you can easily search for most answers on. Ultimately, I'm not going for string streams right now. I'm sticking to the KISS method and keeping it simple for the most part, confining all the code to material that we've actually covered in this course. Once I do have a string constructed, there's already a convenient method written for the input widget that allows setting of the user input string. It occurs to me that I could have made fraction input extend widget instead of being composed of a widget. But this class started life as containing 3 widgets, which made a lot more sense for composition. Now that it contains 1, it might be a candidate for inheritance. Might be something I consider in a refactor, but for now I'm trying to get this code written. At this point, the program does compile, and the input widget does display properly, and it does set the string in the input widget to the value of the associated fraction. That's all good, but it is not yet accepting user input, so that needs to be fixed. User input is captured in the block for input functions. There's actually two of these methods. There's the outer fraction input block for input and the inner input widget block for input. The outer fraction input block for input calls the input widget block for input. This code duplication is possibly evidence for why the fraction input should be inheriting from input widget rather than being composed of an input widget, since it's repeating even method names. So here during testing, I can see that it's mostly grabbing the input correctly, but it also appears to be storing and showing junk data. I can tell because there's some crazy characters showing up on the screen, so there's something to do with the end of the input character array that I need to find. To fix those errors, I add some logic to the set last input method of InputWidget, which will fill the rest of the input array with null characters in order to ensure there's no junk data being stored in it. Now that I've got the input widget essentially working how I want it to, I am just updating my to-do list to include the next step, which is snagging those tokens out of that string in the fraction input widget.